video series, we're going to be learning about repetition statements, which are commonly called loops. By the end of this series, you'll understand the concept of repetition statements, recognize examples of definite and indefinite loops, sometimes called count-controlled and event-controlled loops, and you'll be able to write both definite and indefinite loops using while syntax. So first, before we get into the syntax that we need to create these statements, let's think about what we mean by repetition and why we might need this type of logic in our computer software. So suppose that we're writing a program and we want to find the average of 5 quiz score values. Assume that the end user needs to enter each quiz score individually. So in this case, we're expecting 5 quiz scores as the input to our program. That's what the end user is going to enter whenever they're prompted and they're executing the software. Our algorithm for finding the average is to add up all of the quiz scores to find the total, then divide the total by the number of scores. So it's just taking a normal arithmetic average. And then the output from this program is going to be the average quiz score, that result that we calculate in the processing column. So let's think, how can we write this program using just the statements that we know so far? So far, we don't know anything about repetition statements. So here's a small example Python program that would satisfy this need. We could prompt the user to enter score number 1, store it in a variable called score1, then prompt them to enter a second score and store that as score 2. Prompt them for the third score, store that as score 3. The fourth score, we could store that as score 4, and then finally prompt them for the fifth score and store that as score number 5. Then to calculate the total of all the scores, we could use this arithmetic expression where we say add together score 1 plus score 2 plus score 3 plus score 4 plus score 5 and store the total of those calculations in sum of scores. Then to find the average, we would want to divide sum of scores by 5, or that in another variable called average score. And then finally, we want to be able to print out that calculated value. So we might have a label like the average quiz score is, and then follow that by the name of our variable where we store that average. And if we wanted to store just 5 quiz scores, this solution is absolutely fantastic. It's really not that much to type in. It definitely checks all of the algorithmic boxes, and it gives us our desired end result, printing the average score out to the screen. But now suppose you want to write this program, and instead of just storing 5 quiz scores, you want to store 100 quiz scores. What would that look like? So we could take the same approach. We could have 100 different input statements to read in the value of all the variables. Whoops, I made like typos in here where these should all have float in front of them. You should fix that up in your copy of the notes. If your copy of the notes doesn't have float in here, it definitely should. So you might want to add that in there. But you could have your 100 different lines where you prompted for the input and stored that in 100 different variables. Then you could make a really long arithmetic statement to add up all 100 values and store it in some sort of total variable, sum of scores. Then you could divide that total by the number of scores, which is 100 in this case, and then print out the results. And this type of solution is a little bit more prone to error. So even I made a little mistake here where I forgot to add in the typecasting for all the input statements. So some of them would have been stored as strings and some of them would have been stored as floating point values. And we just had to go in there and add that typecast to fix it up. When you're doing a solution like this where it's really repetitive, it's frequently the case that you'll be copying and pasting groups of code into the solution, and it's really error prone. So this is maybe not an ideal solution. Maybe we could tolerate it for 100 lines, but what if we needed to add 1,000,000 scores? Think about whether that would be practical. Adding 1,000,000 scores using this particular approach would not be practical. Nobody wants to type in 1,000,000 lines where millions and millions and millions of lines are exactly the same, and the only thing that's changing is the number after a particular score variable to help us keep track of which score we're on. And nobody would want to type in the expression to add up all 1,000,000 scores individually. when you just type out the solution like this, like I showed in your notes, it's not that bad because we use these dot, dot, dots, right? And we as intelligent human beings know dot, dot, dot means keep doing the same thing over and over again. You're just applying the same pattern. We did the same thing down here in the arithmetic expression. Dot, dot, dot means keep adding up all the individual scores. I'm not going to list them all here, but you get the idea. And so having that ellipsis, the dot, dot, dot in your solution makes a lot of sense to us as human beings, but the computer will not let us use dot, dot, dot. And that means that typing in this type of solution is going to be really tedious. We'd have to type all 100 lines for our solution that involves 100 quiz scores. And we'd have to have all of the different score variables numbered appropriately. We'd have to have no mistakes in our arithmetic expression that included all 100 numbers typed out by hand. And it would be even more of a challenge if we had 1,000,000 scores and we had to type in 1,000,000 lines of code and 1,000,000 different scores to add up in our arithmetic expression. It would be lots of typing. It would definitely be error prone, and it would be a frustrating and boring experience to create this type of software. The good news is we're not limited to just this type of approach. Instead, the computer will let us exploit the idea that we have to do several algorithmic steps repeatedly, right? We're continually asking the user to enter the next quiz score value. Then we're always adding a new score to the sum of scores. And then at the end, we want to divide by the number of total scores to get our average. So we want to apply this algorithm repeatedly to each of the scores that we need to work with. And the computer has a special kind of instruction that allows us to repeatedly apply an algorithm. It's called a repetition statement. And sometimes we refer to that as a loop. Both of those mean exactly the same thing. If somebody's talking about adding a loop to their program, they're talking about repeatedly executing an algorithm over and over again. And if somebody's talking about creating a repetition statement, they're talking about creating an algorithm that executes over and over again. We already dipped our toe into the repetition statement idea when we were talking about lists. Remember at the end of the lists module, we talked about the for syntax that allowed us to repeatedly apply an algorithm to each element in the list? That was a repetition statement. In this unit, we're going to be learning about a general purpose repetition statement, so it's not limited to just working with lists. And the general purpose statement uses a while syntax rather than a for syntax. And we're going to be learning about two different flavors of the repetition statement. The first one's a count-controlled loop, and the second one is an event-controlled loop. Sometimes those are called definite loops and indefinite loops. Those mean exactly the same thing as count-controlled and event-controlled. A count-controlled loop is a definite loop, and an event-controlled loop is an indefinite loop. And we'll be learning about the difference between the two and looking at lots of examples in this lecture series.